Okay. And I'll also share my screen. Okay. So if I can get this out of the way. Okay, cool. So this workshop is going to be about downloading. It's going to be about downloading Ubuntu. I'm going to cover that very quickly. Uh, my plan is for all of the ASME and RoboSub people that are here, I'm going to be sending this information out to all of you guys right after the workshop. But for now, I'm thinking I'll just go over it. So whenever you go home and you do it, or not go home, whenever you take it after the workshop and you do it, you will you'll kind of know what you're doing. But if I open it up to the side over here, so you're going to be downloading Ubuntu. That's basically one of the distributions of Linux. And to do that, there's a bunch of different ways you can do it. So one way is you can dual boot it with your laptop. So you can have it where, like, whenever you start up your laptop, you have a choice of, do I want to go to Ubuntu or do I want to go to like Apple or Windows or whatever. Um, yeah, but the other way of doing it, which is the easier way, is using this software called VMware. And basically, this lets you make a virtual machine. And all that means is that, like, it just creates a window. So just like if you were playing some sort of game or you were on some other application like Discord or something, and that window opens up, Ubuntu would be in that window. So like you can imagine having like Windows on that window or Apple on that small window. And that's basically what this does. And if you want to use this, your computer needs at least 8 gigs of RAM. So if you don't have 8 gigs of RAM, you're gonna have to do the dual booting version. But if you do, almost all laptops already have 8 gigs of RAM, so you should be good. Yeah, and dual booting, you need to partition your storage. Thanks, Gonzo. And it's a little bit more complicated if you want to do dual booting. This version is very simple as well. Yeah, but just to get started, so first thing you're gonna have to do is you're gonna come here and you're gonna download VMware Workshop Player. And if you can copy this link and you open up a new window and paste it into here, it should bring you to this screen where it says download product and you just press download now. But whenever I opened this up on the Mac, it didn't bring me to this screen. It brought me to a different screen. And let me show you the screen that it brought me to. So it only took like this first line and it brought me to here where it just says all downloads. And it's fine if you come here too, because you can also do, see right here how it says VMware Workstation Player. Right over here to the side, you can press, is it Control F in Ubuntu? Yeah. You can type in workstation, and then it'll take you down to where you see workstation on the screen, and then right here, workstation player, and you can press download product through here as well. Yeah. Um, yeah, so that's the other way to do it. Either one of those ways works. So like after I click this workstation player and I press download product, it brings me here and I can click go to downloads and then it brings me to this screen. The other thing that you need to do after that would be downloading Ubuntu, and you want to get 18.04.5 and just grabbing this link and sticking it into your URL brings you here, and then you can just click on desktop image. This is the one that you want to grab. Click there and it downloads it, and then that's all the downloading that you need to do. You're already finished. And after that, I'm just going to be going through this really quickly just for people that are like watching the recording and don't have the actual document. What you'll do is you'll open up that first VMware that we downloaded from up here. And you'll click on create new virtual machine. It's the huge button right there. And then for installer disk image file, you want to click on the Ubuntu one over here that we just downloaded. And so you can press browse and you can find wherever you downloaded to and just click on that and click open and click next. And then you put in your information for how you want Ubuntu to open up. So just like your normal laptop, you'll have your name and like a username and password, and then you confirm the password. Yeah, and then it's some notes over here. Just don't forget to put in your password because things will get messed up. You'll have to delete it and reinstall it. And yeah. We have a question for virtual machine. Do you need to go to the BIOS and click the virtualization option for some PCs? Yeah, so that's right. Yeah, so for things that aren't a Mac, you'll have to do that. Macs, you're not able to access the BIOS, so you can't do it with a Mac. But for Windows, yeah, that's how you would do it. But Mac, you can. I think it's fine to just follow this procedure. Yeah, so we went through all of that. You choose it, you put in your information, you click next. And then if you want to change where the image is saved, you don't really need to do this. So you can just click on next. Yeah, and then whenever you're creating it, it's going to ask you for a size to make that sort of partition. And it's going to recommend 20. We're going to be downloading a bunch of files onto there, like ROS and a bunch of the coding files that we're doing. So 30 would be like a comfortable amount to use. You won't have to worry too much. And then you also want to select, you don't have to, but it's recommended if you press the split virtual disk into multiple files as well. And then you click on next and you go down. And then over here, you'll see it says memory 4096 megabytes. And if it doesn't say that, you're gonna wanna change it, and you can press customize hardware, and you probably wanna change it to make it 4 gigabytes of RAM. And then you press finish and you're done. You just open it up and then you press play virtual machine and you're finished. Yeah. But I'm gonna be sending these 7 pages out. I'll be sending it right after the meeting, so you guys can set this up. This is your main task for this week, is just try to get this set up and try to get it to work. Can you install it on a separate SSD? Yeah, I think you can. Yeah. Yeah, so there's different ways you can do it. You can put it onto a different SSD. You can dual boot it, or go through this version where you have it open as a window. Yeah, but that's that. So the whole point of this week is just to get this installed. Once you do that, we'll be able to go onto all of like the higher level coding. If you want to do any sort of like higher level robotic stuff, you're gonna need to download Ubuntu so you can work with ROS. So getting this done as soon as you can would be awesome. Yeah, but I'll send that out to everybody after, and that's that. Okay. Yeah, so then now that that's done, okay, awesome. So now this is Ubuntu, by the way. I'm on a separate laptop from the Mac that I was on last time. As you can see here, let me move this. This is in the way. Okay. Yeah, so as you can see here, we're on the Ubuntu desktop. You can see this is the image that you guys should probably be seeing when you open Ubuntu. That's the kind of logo. And yeah, so first, to get started moving around in Ubuntu, if you want to do stuff, so first you probably want to open up the terminal. So there's different ways you can do it. If you see the terminal over here, you can click on it and it'll open this up. If you don't see it off to the side over here, you can click on the 9 dots on the bottom left. And after you open that up, if you scroll down, you should find terminal somewhere in here. Mine is right here. I can open it up from there. And what I'm going to do is I'm going to put the terminal off to the left over here. And I'm going to open up files. There we go. And I'm going to put files off to the right. So if you see here, I'm on my home, like my normal, the home page. And over here, you can see it doesn't really say anything. It just says like the name of my laptop basically. But it has this little squiggly sign here. If you type in LS, these two letters, and press enter, you can see Arduino, Aren Workshop, Catkin Workspace, not Workshop. Um, all of the folders here are over here. So this little squiggly sign means that you're on home. Yeah, so the little squiggly means that you're on home. And let's say you want to go into like Aren Workspace, for example. So over here in folders, you would just double click on it, right? And it brings you here. Over here though, if you want to go into this folder, you have to type in CD. CD is change directory. So it's basically like moving into a folder. So change directory, and then you have to give it the name of where you want to go. So change directory, and then you can type in fully rn_workspace. And you don't need this slash at the end. It's nice if you put it, but you don't need it. This will work as well. So change directory rn workspace, enter. And you see now, instead of this swiggly, it's swiggly slash and then rn workspace. And if I do ls now, you can see the four folders build, devil, install, and source are here. And if you see over here, there's the .catkin workspace file, and it's not showing up here. So files that start with a period don't show up whenever you type ls. So like if you want to hide a file or something, you can put a period in front, but it's not a great way of hiding it, because if you want to show those files, all you have to do is ls and -a, space -a. And this -a just means like all. So if I press enter now, you can see it shows the .catkin workspace. And it also shows these two over here. It shows a single dot and it shows two dots. And there's a good use for this. So let's say I want to go back to this home folder over here. So to go back, there's two ways you can go back, or three ways, but two that we're going to cover right now is change directory, and you can put the little squiggly sign, and you press enter and see how it came back. It came back to here. But if I go back into RN workspace, I can also do change directory ... and press enter, and you see it came back. It came back to here. So you can do it two ways. You can either do change directory and put in where you want to go, or change directory ... And the reason ... is helpful is because, like, let's say I go into here, and actually, let's say I want to go into this source folder. Can somebody tell me how I would go into this folder? What's the command I would write to go into this folder? Okay, right? Right, exactly, yeah. So change directory, source. Yeah, so change directory source, you type that in and you press ls, and now I'm in this source folder. And over here, this photo is in the way. If I open up the source folder, you can see all of the stuff here is the same as all the stuff here. So now I'm in this source folder. What happened? Oh, okay, never mind. Yeah. Yeah. Oh yeah, by the way, if you run into any errors earlier with downloading that Ubuntu and getting all of that stuff set up, feel free to reach out to me on either ASME or RoboSub, whichever Discord server you're on, or just send me a DM. and I'll try to help you out as best as I can. If you're on the RoboSub server, you can also send the message to Ricardo. He knows that stuff a lot better than I do, so he can help you out as well. But yeah, okay, cool. So then we're in the source folder, and one thing I was going to show you actually is now if I go back, let's say I want to go into Aren workspace. If I was doing it the long way, change directory, I would have to put the swiggle and then slash rn underscore workspace. And I would have to write this whole thing out if I wanted to go back one folder. And that would take me back to here, right? But if I'm in the source folder, I can just use change directory dot dot, and it brings me back one folder. Another fun thing is if you want to go back two folders, you can do change directory dot dot. Oh, you have to put a space. Change directory dot dot, and then slash dot dot. And that takes you back two folders. And then you can put 3 or 4 or however many folders you want back. And now we're back here in the home folder. So one thing I was going to show you again, another like kind of shortcut is you don't have to type in the entire name. So cd change directory. You can see here the only folder, because this a.py here, this is a file. The only folder that starts with a lowercase a is this rn workspace. So after I do change directory a, if I just press tab, it fills in the rest for you. So if I just press ARE and press tab, it'll fill in the rest. A and tab, it fills in the rest, and you don't have to worry. But let's say like over here where you have this public folder and this pictures folder, if you do change directory and you just type in P and you press tab, nothing happens. It doesn't want to fill it in. But if you press tab twice, it'll list your options. So it'll say, okay, either pictures or public, make up your mind. And then you say, okay, I want the pictures one. I put an I in there, and then you press tab. Okay, now it knows which folder that you want. Yeah. Yeah, okay, cool. Let's see, where else? Okay. Yeah, so now I'm gonna go into my workspace and I'm gonna go into my source folder. And see how we're getting kind of to the bottom of the terminal. I can keep writing like ls, and you see how things get kind of messy. Like we're just gonna keep going down. So one thing you can do is you can type in the word clear and press enter, and it just clears the entire thing. If you do it on accident or something, you can always scroll up and it's still there, but it just like, creates a fresh kind of page for you to use. Yeah. So then over here now we're in the source folder, and there's a bunch of different folders in here, but but there's different ways you can make a folder. Let me go back into here, source. You can right click over here, obviously, and you can press new folder and then you can put the name in. So like if I go over here, let's say, and I go new folder and I say like my folder, you see it made a my folder, but over here it didn't update. So I typed in ls earlier, but it didn't update for me. So now if I do ls again though, you see right here a my folder shows up. Yeah, but I'm gonna delete it from over here, and then we'll type in ls over here, and then my folder's gone now. And the way you can make a folder just using the terminal is mkdir. That's make directory. So instead of folders in the terminal, they're all called directories. So like change directory, cd, make directory. And then here you put in the name of your directory. So let's say I want to call it my folder. Make directory my folder. And if you watch over here, once I press enter, my folder pops up. And now let's do ls, and you can see my folder is here. And let's change directory into my folder and press enter. And now we do ls, and there's nothing that shows up. We click into here, it's because there's nothing here. It says there's nothing in your folder, and you type in ls and nothing shows up. Yeah, but that's that. But what we can do is we can put a file into here. So let's say I want to just put some sort of text file. I want to take note of something. Like I'm in the middle of class, I can put in nano. So this nano lets you create like a text file and edit it immediately. And it lets you edit files. This is a great little tool to have. Yeah, so if somebody could link that for Cecilia. Yeah. So you type in nano and then you put in your file name. Let's say I want to name this one, I don't know, anything random, ASDFG, whatever. And you press enter. You see now it brings you to this page and it created this ASDFG file over here. And if I type something in here, like let's say I want to type like, hey there, I can type other stuff underneath, but to get out of this, you see in the bottom here, it says, it has this up arrow and it has X. So if you do Control X, it asks you, do you want to save what you've done? You have to click the letter Y, and then it tells you what's the file name that you want, and all you have to do is just press enter, and that's it. And now if I go ls, there's a file that was created, and if I want to edit that file, nano asdfg, you come back in here, and then just Control X, and it takes you out. If you don't make any changes, you just do Control X, and it takes you out. If you make a change, like I put a space bar here, now I do Control X, it says, do you want to save? Y, enter. Yeah. But let's say this file is garbage or something, I don't want it, I just think it's extra. I can do RM, and this RM is remove. And I can do RM, and I don't even have to put the letter A, I can just press tab, and it already knows because that's the only file in here. So I can just do RM space tab, and press enter, and the file's gone. So now if I do ls, you see there's no files in here anymore. Yeah, but what I'm gonna do is I'm gonna make another file. Let's name this one, sure, QWE. And in here, I'll write something like, what's up, guys? And press Control X, Y, enter. And now we have this QWE file. If I click it over here, you can see like it's just a text file and it just says that. Can I grab it? There we go. Can exit out now. Okay, the zoom bar on here is huge. Yeah, but now we have this QWE file, and there's different things you can do with that file. So one thing you can do is CP. This CP means copy. And first you put in the name of the file you want to copy, so QWE, and then you press space, and then you can put in the name of the file that you want the copy to be. So like let's say I put ASD. So copy the QWE file and name it ASD. So I press enter and ls. Now you see that there's an ASD and a QWE file. And if I go nano ASD, this has what's up guys in it. And if I go nano QWE, it has the same thing in it. Oh, whoops, pressed the wrong key. Nano QWE, and then we can exit. There we go. Okay. Yeah. Okay. Okay, so then one thing I'm going to show you guys, let's say you have like a long text file or something. So let's make, let's go nano ASD. We have this what's up guys. Let's say I put ASD, ASD. I'm just going to put a bunch of random letters just like this. So we have a bunch of random letters in this file, random just different words. and I press Control X, Y, Enter. Let's say I don't want to go nano ASD every single time, and like let's say I have a bunch of files here and I just want to see what's in it. If you type in the word head and then put in your file name ASD and press enter, it'll list the first like 10 lines of your file. Now, my file is less than 10 lines long, so it just listed like everything in the file. But if you put head, it'll show the first like about 10 lines of this file that you give it. So like if I do head QWE, it'll only show that what's up guys that I had in there. And let's say you don't want to see the first 10 lines, you want to see the last 10 lines, you can already guess that's going to be tail ASD. And the first 10 and the last 10 are the same, so it just shows the same thing. Yeah, but that's that. One other thing I can show you guys that's important in here, you're probably going to use a lot, is the move command. So the move command is MV, and then you give it your file. So I want to move ASD, and then you tell it where you want it to move. And there's different ways you can do that. We talked about that earlier. Is you can go with a squiggly and then go Aren underscore workspace and then slash source and like put it in there. And if I press enter now, you see the file disappeared over here. If I do ls, it's gone. And then I go back and I do ls, ASD is in here now. So my ASD file just moved back because I moved ASD to this, and now I'm in here. So I'm going to press clear because we're getting down to the bottom, and I'll do ls again. And we see our ASD file is here. And let's say I want to move it back into the folder. I can do move ASD. And instead of typing the full file like length, all I have to do is underscore my folder and press enter. And ls, and the file is gone. And then change directory, my folder, ls, and the file's back into here. Okay. So we talked about removing stuff. So like if I do rm ASD, it'll just remove that file. But let's say you have, let's say you're working and you have this huge folder and it's taking up space or something and you want to delete it. So you can go over here and you can do that with the file manager, file explorer, whatever you call it. You could do that here, or if you just want to do it in the terminal, you don't want to be bothered opening that up. Let's say I want to delete the my folder directory. So if I do remove my folder, this actually doesn't work because if I press enter, it says you can't remove my folder since it's a directory. So you can't just remove an entire folder if there's a bunch of stuff in that folder. So what you would have to do is you would either have to go into the folder and delete everything, or you do remove -r my folder. And this -r means recursively. And what that means is it'll go into the folder and it'll delete every file that's in that folder, and then it'll come back and it'll delete the folder. So like if you have a folder and there's folder in that and there's files in that one and you want to delete the first one, it'll go into that folder, then you'll go into the next folder and it'll delete the files in that, then it'll delete that folder, and then you'll finally delete the first folder. But so if I just do remove recursively my folder and I press enter, and then I do ls, you see my folder is gone. It removed all the files. It doesn't give us an error. It just gets rid of everything. And yeah. So that's all of like the basic stuff you need to know. So there was ls, there was cd, there was make directory. What else was there? There was remove, nano, or I guess nano and remove and move and copy, or copy and move. I don't know if I'm forgetting anything, but those are like all the basic ones that we just went over. Another thing you can do is, let's say you want to work on two files at the same time. So like Do I have two files in here? Let me just make two files right here. So I'll do nano ASD, and I'll put ASD in it. Sure. Now we have that ASD file, and then I'll go nano QWE, and I'll just write like QWE in it. And now we have this ASD file over here, and we have this QWE file. And let's say you want to edit both at once with the terminal. So the way you can do that is on this one, you can say like nano ASD and open it up. And then there's different ways that you can make new terminals. So one way is with Control Alt T. So Control Alt T, and that just made a completely new terminal over here. And over here I could do, well, see, it brought me back to the very beginning. So it brought me back to the home page over here, and I'll have to navigate back to where this is. That's one way to do it. Another way is Control Shift N. And when you do Control Shift N, whoops. It's annoying. There we go. And when you do Control Shift N, it brings you to the folder that you're in. So Control Alt T brings you a brand new fresh terminal, and Control Shift N brings you a terminal with the folder that you're in. So those are two shortcuts you're going to want to know. I mean, you can also right click over here and just press new terminal. That'll open up a fresh one for you. Or you can do Control Shift T. And that opens a second terminal, like a second terminal tab, basically. And then you can like grab this tab and pull it out. Maybe you can't pull it out, never mind. Yeah, so then you can either work in these two tabs, or I very much prefer just working on a new terminal completely. Oh yeah, but what I was going to show was that, so like if I put that one on that side, I can split this one on this side and do nano QWE, and now I'm working on both at the same time. I'll close both, and I'll close this one down, and I'll press clear. Yeah, so that's all of the most basic stuff that you're going to need whenever you get this Ubuntu and you want to use the terminal. If you want to use ROS and you want to learn the state machine and computer vision and all that stuff, you're going to have to use the terminal. So it's great to know like all of those commands and like all the shortcuts as well, like tab and the opening terminals and stuff like that. Yeah, one thing I was going to show was, oh yeah, so this squiggly sign, this isn't actually the end of your folders basically. So what we're on is we're on AUV Club laptop. This is like one of RoboSub's laptops. And if I go change directory and I go over to the squiggly, this is like my home page. But there's actually pages before your home page that you're not really supposed to go to, but you can go to. So if I do PWD, this is print working directory. And it basically gives you like the absolute folders of where you are. So like if I press enter, it tells me I'm in /home/AUV Club laptop. And these are two different homes. This home here and this home here are two different homes. So like if I go change directory and I go into Aren workspace and now I do PWD, we're in home, we're in AUV Club laptop, and then we're in Aren workspace. But if I want to go back to like the serious home, I can do change directory back like this. And now you see we're in /home. And if I type in ls, it says AUV-Club laptop. And if I go into AUV Club laptop, it just brings me to the squiggly, right? But if I go change directory back, and then I go back one further than that, now I'm just in /. And this / is the farthest back that you can actually go. And if I type in ls here, this is where all of the folders that you don't want to edit are. There are things that you might want to do here, like you might want to change, like this is where your laptop gets like its booting information from. and your root and your system and all of your important stuff are here. Um, but yeah, like you might, like sometimes some tutorials might tell you like go and edit your boot or edit something. Um, so you might have to come here and change stuff, but for the most part, stay away from here if you can, because if you go here and you mess things up, it might actually mess up some actual stuff in your laptop. So what I'm going to do is I'm going to change directory to home and AUV club laptop, and I'm going to come back to the safe swiggly sign. And yeah, Gonzo, those are the system files. But yeah, and then there's also another thing called sudo, and this allows you to do things. Basically, sudo is super user do. That's what it stands for, and it allows you to like override your laptop. So if some tutorial tells you like to edit a certain file and add something in, and you try to do it and your laptop doesn't let you and it says you're not allowed to edit this file or something like that, if you do sudo, that sudo lets you go in and it'll override the laptop and it'll say, no, I'm in charge, I know what I'm doing, and it'll let you do like the more advanced things that you're not supposed to be touching but that you might need to touch. um, but yeah, those are all of the basic commands in here that I know of. One thing I was going to show you guys after all of that was, after you get this, you can actually get started with like basic Python stuff if you wanted to, and you can do that with just Nano as well. So when you do Nano, there's actually different ways you can there's different files you can make, is what I'm trying to say. So if I do Nano and I do like my ASD from before, I can do like ASD, and then if I just do nano ASD and I press enter, it'll make a text file. It'll automatically just make a text file. But if I go back and okay, it didn't make it, nice. And I go nano ASD, I can put a period after it and I can decide what kind of file I want to make it. So if I put like .text, nano ASD.text, it'll automatically make this a text file. And that's not that great because it was a text file anyway. Okay, I'm just checking that it doesn't actually make the file, and it doesn't. If you don't type anything, it doesn't make the file. But what I was gonna say was that here you can actually make a Python file. So like, let's say I don't have a test file in here. So let's say I do nano test. The extension for a Python file is .py. And this will tell your computer this is a Python file. So nano some name .py, that would be a Python file. And like text files, you know, is .txt. HTML files are like .html. C++ files are .cpp. So every file has like a certain kind of extension. Python is .py. And if I press enter now we're coding in Python now. This is like the most basic coding in Python. And the nice part about Python is you don't need all of those void, whatever it is. I already forgot. Void loops and begin and all of that stuff. You don't need any of that. Like if you want to run a Python code, all you would have to write is like, let's say print, and see how it turned blue? It already knows like we're doing Python now. So like you go print, and then let's say I want to print, I don't even need parentheses. I want to print the word hello. And when you're in parentheses, it turns it automatically green. I can just write print hello, and I'm in the test.py file. If I go Control X, Y, enter, and I type in ls, right here, we made this test.py file. I'm gonna press clear. So up here, we made this test.py file. Let's say I want to run that file. So I can just type in Python. That's the command. So instead of nano is edit, we type in Python, and then we give it the file. So like I give it test I could just write like T and press enter, test.py. Now if I press enter, it printed hello. So it printed hello right here. Oh yeah, one thing I completely forgot to say is if you wanna go to your history, like of your terminal, and like repeat a past line or something, you can just press the up arrow. If I press the up arrow once, it'll just copy the last line. Or if I press it again, it'll go to the line above that. Or again, I press clear above that, ls, nano, and it has a full history of all of the commands that I've run. But I can just press up and do it again, and it prints out hello. So I can just go up here and I can go nano test.py, and like underneath this, I can say print. Let's make this one hello there, and make this one General Kenobi. And then now if I go print, it prints out two separate lines. You don't even need like Arduino's ln at the end of it. Python is extremely simple. It's actually like very easy to guess like what how to set things up. It's like very intuitive. So like certain things, like if you want to make a variable, yeah, it's simple, but it's very powerful. Yeah. Like if you want to make a variable, you don't need all of this int x equals 15 and then put a semicolon at the end. You don't need all of that. Literally all you would have to do is x equals and whatever, and you're done. You don't need the type of variable in front, and you don't need a semicolon at the end. If you see here, I didn't put semicolons at the end. It's literally just variable name and then what the variable is. So like here, I could, let's say I want to put in x is equal to 5, y is equal to 7, and then I'll delete this. And then I could print out literally, well, for now, let's say print x. And underneath that, I can say print y. And that's all I write. X is equal to 5, y is equal to 7, print x and print y. And then Python, and it just printed out, whoops, it just printed out 5 and 7. And then let's say I want to do like more advanced stuff. I can say, let's say answer is equal to x plus y. Very simple. So my answer variable is equal to x plus y. So 5 plus 7. So answer should be 12, hopefully. If I did my math right there, answer should be 12. And then over here, I could say like print answer. And then I run Python, and now it prints 12 out. Or if I want to make this very fancy, this is like going a little bit overboard, is you can put x, comma. If I put x, comma, answer right here, and I just press save, and then I ran Python, it prints 5 and then space 12. But let's say I want to do, you guys probably already know where I'm going with this, is let's say I want to go 5 plus, whoops, and you can put as many of these as you want. So 5 plus y equals answer. That's my line. So x, and then the plus sign, y, and then the equal sign, and then answer. So this will plug in 5, and then plus 7, and then it should say equals 12. And let's see if I did this right. And I do Python, and now it prints out 5 plus 7 equals 12. And that's like one of the most basic stuff, like just with using prints, is you can, is the nice part about this is basically with Arduino, that online software is nice where you can put in all of the, where you can put in like wire things up and get it to work and everything. But with the actual Arduino, you have to have the Arduino plugged in, and you have to type up all those lines, and then you have to press upload to the Arduino, and then it uploads to the Arduino, and then finally the Arduino sends back like 5 plus 7 equals 12. With this, you literally just type it right here, and you press save, and then you press Python, and it runs it automatically, and you're done. And that's all there is to that. Yeah, and there's a bunch of things you can do if you guys manage to get Ubuntu by the next time. you can go ahead and mess with whatever you want in here. Um, you can put in extra variables. You can make arrays on here. Almost everything you can do in Arduino, you can do in Python and plus a bunch more. So this is a great place. This is a great not software, a great coding platform, I guess, to use. But yeah, there's that. Let me remove that file. Awesome. Yeah, okay. Were there any questions so far on all the stuff that I did? I just realized I haven't really been stopping to ask for questions. Are we good so far? Is all of that pretty simple? I think the hardest part of all of this is just downloading Ubuntu. If you guys manage to do that, you're set for the rest of the semester. Yeah, practice. Like if you want to move around in this, you slowly type in CD and then look at your directory, and then you can type it in and then you're done. But once you're familiar with this and you're familiar with all of your folders, you can just really quickly go change directory source. Okay, I want to go into here. Okay, here, let's go into here, and then I'll go into here. Like you're really quickly, you can zoom through it, and you know where you're going. Flex, yeah. No, but you guys, in with like a few weeks or like a month of practice, you'll be able to quickly zoom through. You don't have to type every single folder out like I just did. If you know the folders, you can just do that, and it'll automatically take you the full way. You don't have to go one by one. But yeah, we have a few extra minutes. What I was thinking is I could show you, since nobody has any questions, I could show you guys some of the stuff from both ASME and from RoboSub. Yeah, okay, it doesn't seem like anybody has any questions, right? Am I good? Good, okay, awesome. Doesn't look like we have any questions then, okay. So one thing I was gonna show you guys was just a couple of codes from like both of the teams, just to get you familiar with like what we're gonna be doing. Where is it? It's not here. It's in here, right there. Okay. So like for clear, please. Okay. Whoops. There you go. Nano waypoint nav. So this is like one of the codes for ASME. And this code, I like it a lot just because it encompasses like literally all of the things that we're going to be teaching you in the next 2 months. So like the next 2 months is literally just going to be so that you'll be able to completely understand everything that it says here. Maybe not yeah, I guess 2 months, yeah, a few weeks. Yeah, so like this first line, you're going to have to figure out why is this line here? Why does it need to know that it's Python? Figuring out how to import all of these libraries. These 3 libraries I kind of made myself. We're gonna like teach you guys like how to make those. And then in Python, it's instead of like void, we have classes and stuff. And then we have states for the state machine, initializing in Python, self, and putting things into self. And then state machine stuff right here. We have ROS subscribers and ROS publishers. Like this code literally has everything that we're planning to cover. And we'll teach you all of this Python coding as well. But yeah, this is like the waypoint navigation code. This is all there is to it. This is like one of the states where we're using the GPS and we're trying to navigate from one place to another. And we have like latitude, longitude here and latitude, longitude there. And we angle ourselves and we head in that direction. That's basically what this code does. Never got to test it, sadly. Hopefully, once we get the robot out and we get stuff working, we'll be able to actually test it out and see if it works. But yeah, so this is like the final kind of thing that will hopefully get you guys to. That's like one of the ASME states. Another one I could show you guys is the, oops, there we go. Where was it in? Should be in state machines. Yeah, there it is. So this robo task like 123, this is one of the state machines. So if I do Python robo task 123, and now we're running Python, it wants me to run ROS core. And then after that, I can open this one up and I can do ROS run smash. So you're definitely going to be needing like a billion different terminals like this. And it runs, and there we go. And then I can go full screen for you guys and focus. It's like this is like the RoboSub. Yeah, there we go. Okay. And this is like the RoboSub, like the general kind of outline of each task, or like the general task thing that we're going to be doing. If the Robo people remember from like one of our presentations, we talked about how we're having like a search state. And if you see task one, you head over to it and you do the task one things. And then you go back to the tracker and then you keep going. And then if you see task two, you do that. And then you go back and then task three and you do it. And you keep track of whether you passed or failed every task. And after you passed all of them, you go all tasks finished and you finish and you're done. And that's like one of the RoboSub things that we're doing. If I close that and I close this and I open up Robo Gate task one. What's wrong? Gate task one. There you go. Okay. Oh wait, no, that's not it. Python Robo Gate task one. Okay, now it's running, and then I do this. And then I go full screen with this guy. I need to focus it first, I guess. Okay, there we go. That's good enough. So like, let's say for the gate, where we're underwater and we have a gate and we need to go through it. Like the first task would be just like driving around until you see the gate. And then once you see it, like target sighted, you start centering yourself. So you want to be in the center of the gate. Once you're centered, execute state would just be like go full speed forward, go through the gate. And then once it's executed, you head it off to the tracker. And then this is like one of those tasks. So like that task one on the side might be like the gate task, and that's split up into more different, like a bunch of different other states. And then these states could be split up into other states and like so on and so forth. And this applies for ASME one as well. And if I X that out, and I close that. It's another thing that I wanted to show you guys while you're still here. I'm just showing you stuff that we're going to be working towards. We'll be teaching you all this, so don't get scared by anything. Yeah, don't worry about any of this stuff. If I open this up, oh yeah, it was take one. There you go. Okay. Python ASME take one.py, and then run this. And then go here and go here and go autofocus. Oh, didn't want to autofocus. Let's open it back up. Open this up. There we go. Okay, it's already autofocused. Nice. Okay. Yeah, so if you guys remember from like one of the ASME presentations, this is the general outline of their state machine. Like you start up the robot and then you start detecting lanes and then you start detecting all of the objects. And there isn't any code. Like for RoboSub and for ASME, there isn't any code really in any of these. It's literally just like the name of the state. Besides like the initialized robot, that's like the only state that we've really completely finished. And that still needs to be tested as well. But all of these little states and all of the RoboSub states, like all of those still need to be coded. And after we get all of you guys caught up on everything, we're hoping that you can help us out and try to get the code done and get that robot moving. But yeah, so that's that. Yeah, and Yeah, okay, see you, Kat. Yeah, this is all done with ROS. All of this stuff, like if you see I wrote ROS run, that's one of ROS's commands is using ROS run. This is, yeah, doing all of this and starting to work on all of this is the end goal, yeah. Uh, yeah, so like we're gonna be, for the next like 3 or 4 workshops, basically we're gonna be going over this. So if I search up ROS tutorial and I click on the first link, you'll see here, if it lets me grab the window, there we go. You'll see here, it brings you to this ROS tutorials page. And these are like the beginner level ones. And realistically, these are like the only ones you really need is these first like 20 or so. And most of them are pretty simple. So like if you start off with the very first one, this is basically like installing ROS. And it tells you, okay, type in print environment and whatever the vertical line is called, and then grep ROS, and then it tells you run source like this, and it tells you make a directory. We already know this one, right? Change directory, we already know that one too. Then they have their own command, cat can make, and then it says run source, and then you're done. Like that's the first tutorial. Okay, awesome. Now we go back to tutorials. Okay, now we're ready for tutorial 2. And basically the next few workshops is going to be going through all of these, basically helping you guys out, going through all of the commands and making sure you guys aren't confused. Like whenever I spend last year learning all of this, like it gets very confusing. There's always some line in there that you mess up on. Like for example, for this one, for the very first one, like it says here to use this, to type this line, right? And if you just go and you copy paste this line, it doesn't work. And the reason it doesn't work is because we didn't read the note underneath. Is that you're supposed to use the name of your ROS distribution. So instead of this distro here, you need to put in the name. So like over here, like if you're using kinetic, you type in kinetic, and then you put this line into the terminal. And if you're using melodic, you put melodic. And there's different ones that you can use. We're going to be using melodic, and we'll teach you guys in the next workshop how to get all this set up. But just try, if you can, just try to get this Ubuntu working. If you don't, and if you're having problems, just message us on Discord. We'll try to help you out and get it up and running before the next workshop, so that you're not behind whenever we're starting with all the ROS stuff. Yeah, so that's ROS. So not let me close it. There we go. Yeah, okay. And there's different stuff you can do. Oh yeah, there's ROS run turtle. Is it turtle sim? It's not right. Turtle. Let me see here. That's weird. Whoops. If I do. Okay, yeah, there was a letter in front for some reason. ROS run turtle. What? Turtle sim, yeah, that's what I said. Okay. And then like turtle sim node over here. It opens up this little turtle guy. This is one of the ROS tutorial things that we're going to be working on. Another one over here, if you do ROS run turtle sim turtle underscore teleop key, it says use arrows to move the turtle. So if I use the arrows here, it lets me move my little turtle around. And they show you like how the coding for this works and all that. And then, yeah, oops, wrong way. Awesome, yeah. There, it's my badly shaped heart. Yeah, and then you can close this down, and you can close this down, and then X everything out, and we're set. If it lets me, X my things out, there we go. Yeah, but that was everything that we're going to be covering. CS team is basically controls. Yeah, basically, yeah, we're going to be controlling turtles. That's our end goal. Yeah, but that was everything. Those are I went a little bit extra there, just trying to tell you guys like in what the end goal of the CS team really is getting up to all of those state machine stuff and all of that higher level stuff and working on all of that. So hopefully in the next few weeks we'll teach you guys ROS, and then a few weeks after that, and the few weeks after that we'll teach you state machine, and then computer vision, and you guys are set to work on all of the coding stuff that we're doing right now as well. Yeah. If there's no questions, I'll just stop the recording for now. Anything? No, we're good. No questions? Awesome. It's a relevant question, but could you explain what bash or bash RC is? Yeah, so bash is a little bit like I'm not exactly like super familiar with it. I've only used it a little bit. If you make a bash file, like I can make a bash. Well, actually, I think you have to first nano the bash file. So like if I say like nano test.bash, I believe this makes like a bash file, and then in here you can type in a command that you want it to do. So like let me open a new terminal really quickly. What's something in here that it could run? Like ASME underscore task one. So like I think I forget the exact thing. I think you can literally type in exactly what it does, and whenever you run this file, it'll run those commands for you. I should have an example here somewhere. Hold on. Is it in here? Launchers maybe? Yeah, I have some bash files in here. Yeah, here we go. Okay. Yeah, so like this is an example of a bash file. Like you put it into, you say it's a bash file, and then you say sudo in a new terminal, and there's just a bunch of stuff that you have to add after it, and then just like literally tell it exactly what to run. So I could do a quick example for you if you want. Like here, if I made a nano a dot, oops, nano a dot py, and this is a Python file, and I just say like print hello, this a.py is going to be printing hello, and I'll save that really quickly. And then I'll go nano a.bash, whatever. And now we have a bash file, and go like this, and go here /bin/bash. And then here we type in sudo gnome terminal --sh-c. And then right here, we can literally type in the exact thing we want it to run. So like if this was, if we were normally trying to run this a.py, in here we would type in python a.py. Oh, am I not sharing screen? My bad. Yeah, okay. Sorry, I was going through all of this whole time, yeah. Yeah, so I was saying, shoot, I should probably go through this again, my bad. So if I do ls here, I made this a.py file. And if I do nano a.py, all I wrote is print hello. Just print hello, and that's all a.py does. And if I wanted to run this file, I would just write python a.py normally. But I could also make a bash file, and in here I can say sudo, I can write like all of this stuff out. I put an example up over here, and I can put in python a.py bash into here. So this python a.py, so now it's in here now. If I save this and I type in ls, I have an a.bash and this a.py. And if I run the bash file, it'll run all of that code. So like if I do bash a.bash, if I do bash a.bash, you have to give it your sudo password, and it just printed hello. So it made a new window and it printed hello. And if we look at the bash file, it says make a new terminal and then run the Python code, and the Python code just printed hello, and that was all there is to that. I'm running over on time, so I should probably X out my 200 terminals. Yeah, but that was a quick example of a bash file, yeah. Bash RC, I don't know too much about. I don't know what the difference is, to be honest, but that was what bash is. But yeah, I'll close all of this stuff down. Was there any other question, or was that it? We're good? Okay, awesome. Went 10 minutes over, but I'll stop the recording. Thanks everybody for coming.